Hello and welcome to MyScience Tutorials. In today's video, we are going to be talking about integration by substitution of an indefinite integral. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing the notification button so that you do not miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So we want to first of all start by looking at an example of how to solve an indefinite integral using the method of substitution. Alright, so the first example, I'm to integrate the function x, the root of 1 minus x squared dx. Alright, so this is the question and I'm to integrate it. So let me write down the solution. Now, because we have two functions, that is, the first function is x and then the second function is having a root sign, we need to find a way of simplifying this function so that we can integrate it easily. And one of the ways we do that is by using substitution. So for instance, to solve this question, we said let any variable at all, let's say u, be equal to what we have in the bracket over here, that is 1 minus what? S squared. Now after we use another variable, okay, to represent what we have over here, we differentiate it, okay. So if we differentiate u, we have x over here, so we differentiate u with respect to x, so we get, if we differentiate this, 1 is a constant, so we differentiate a constant, we get 0, so that is gone. If we differentiate negative s squared, it means we still have the negative, we bring the 2 here, then we subtract 1 from the power, so it becomes x power 1. So if we differentiate 1 minus s squared, we get negative 2x. Okay, so now that we differentiated this, we can see that we have the x over here. So let's make the x the subject over here. If we make the s the subject over here, we are going to get what? Du over negative 2x. Okay, so now we can rewrite everything over here as this, then root of, we say let 1 minus s squared be what? U. So we have u dx over here, okay. But we said what? Let dx, okay. But we made the s the subject over here, so which is what? Du over what? Negative 2s. So if we substitute this back over here, we now have the integral of x root of what? U, okay, multiplied by the ds now will become what? Du over what? Negative 2x. Okay, so we can rewrite everything over here as, because they are all multiplying, okay, and we know multiplication is commutative, it means I can bring the negative 2 under this, so it will become what? I can rewrite everything here as what? X multiplied by what? Root u multiplied by what? Du, okay, all over what? Negative 2x. And I can write this as what? X over what? Negative 2x multiplied by what? Root u what? Du. This is still the same as this. Okay, so from here I can see that the x will cancel this. I'm left with what? 1 over negative 2, and that becomes a constant. Okay, so I have integral 1 over what? Negative 2 multiplied by the root of u du. So because this is a constant, let me bring it outside so that I just integrate what I have. So I have negative 1 over 2, the integral of what? U raised to the power half. The root of any number or value is the value raised to the power half, then du. So all we have to do from here is just what? Integrate the function u, and then we find our answer. So we have half, okay. Now if we integrate u, we have u power half, then we add 1 to it and we divide all by what? The new power, which is what? Half plus 1. Then we add c to it, okay. Alright, so it means we have negative half, okay, then into bracket. Now if we add 1 to half, we get u raised to the power 3 over 2 divided by what? 3 on 2, okay, plus c. Let me just write it like this. So I have half, okay, then if I bring the denominator here upward, it becomes what? Multiplied by 2 over 3 u 3 on 2 plus c, Okay, so these two will cancel this, so I have negative 1 over 3 u raised to the power 3 on 2 plus c. Okay, and I can rewrite this as negative 1 over 3, okay, the root of what, u cubed, okay, plus c. Okay, but remember we did substitution where we said let u be what, 1 minus what, s squared. So we substitute the u back, so we now have 1 over 3, negative 1 over 3, sorry, root of what, 1 minus what, s squared all cubed plus c as our answer for integrating the function s root 1 minus s squared ds. Alright, so let's have a look at another example. So the second example we want to look at is the integral of the function 2x minus 5 raised to the power 7 dx. So let's write down our solution. Now we can see that the function in the bracket 2x minus 5 is multiplying itself 7 times, okay? And if you want to expand that, it's going to be very, very long and very tedious. So we need to find a simpler way of integrating this particular example. So the most simplest way of doing this is by the method of substitution. So we say let the function in the bracket be u, okay? So we have 2s minus 5. So we now differentiate the function. So if we differentiate u with respect to s, we get what, du ds, and it becomes what, if we differentiate 2s, the power of the s here is 1, it multiplies the 2, we still have what, 2. Now we subtract 1 from the power, it becomes 0, so x raised to the power 0 is 1, so it's still 2. Now if we differentiate the 5 over here, it's a constant, so we get 0. So if we differentiate the function 2x minus 5, our du ds is just what, 2. Alright, so let's make ds the subject. If we make ds the subject, we get what, du over 2 as our answer. Alright, now that we have this, let's go back and then what, bring our equation back. So we have the integral of what, 2x minus 5 raised to the power 7 dx. We are saying, we said let 2s minus 5 be what, u, so we have the integral of what, u power 7 dx. But remember we say what, or remember we made ds the subject over here, where we are saying ds is equal to what, du on 2. So if we substitute ds in place of this over here, we now have the integral of u power 7 what, multiplied by what, du on 2. Okay, so this can become the integral of what, this is on 2, so we can do that as half multiplied by u power 7 what, du. Because this is a constant, we bring it outside the integration sign, so we have half the integral of u power 7 what, du. So we have half. If we integrate u raised to the power 7, we have u power 7, we add 1 and then we divide by the new power that we have, which is 7 plus 1. Then we add the constant c, because we don't have limits to the integration, so it is an indefinite integral and we need to add the constant c. Alright, so from here we have half raised into bracket, then we have u power 8 on 8, okay, plus c. Alright, so from here we can see that we have half multiplied by u on 8, u raised to the power 8 on 8 can be rewritten as what, 1 over 8 multiplied by u power 8 plus c. So if we multiply these two fractions, we get what, 1 over 16 u power 8 plus c. Okay, but remember we said what, u is equal to what, 2s minus 5. So it means we have 1 over 16, okay, into bracket 2x minus 5 raised to the power 8 plus c as our answer for integrating the function 2x minus 5 all raised to the power 7 dx. Right, let's have a look at one final example. Alright, so example number 3, we have to integrate the function 2x on the root of 4x squared minus 1 dx. Alright, so looking at this question, we know we cannot integrate directly, so we need to use what? The method of substitution. So as usual, we say what? Let u be the function we have at the denominator over here, that is 4x squared minus 1. If we differentiate the function, we get the u dx to be equal to the 2 multiplied by 4, we get 8x. This is a constant. We differentiate a constant, it becomes 0. So we make the s the subject over here, we get what? Du on what? 8x. So we can rewrite this whole integration as what? The integral of what? 2x on what? The root of u dx. But we made the x the subject and we said it is equal to what? Du on what? 8x. So if we substitute this in place of this, we get what? The integral of 2x on root of what? U multiplied by our ds is now what? Du on what? 8s. Now from simple mathematics, I can rewrite everything over here as what? 2x on 8x multiplied by what? Root u. Okay, sorry, I bring this over here, so multiplied by what? Du on root u, that is what? I bring the, let me use another color to indicate that, which means I brought the 8s, okay, over here, and I brought the root of what? U in place of this. Okay, so I just switched their position, but it is still the same. Alright, so from here we have what? The integral of, we know s will cancel this, here will go here 1, it will go here what? 4. So we have 1 over 4 what? Du on what? Root of what? U. So if we bring the 1 outside, we have 1 over 4 integral of what? This can be rewritten as 1 over what? Root of u du. Okay, alright, so we have 1 over 4 integral of what? U. Let's write it in a linear form. So if we bring the u to the top, it will become u raised to the power negative half. Root u is u raised to the power half, but because it is inverse and we want to write it in a linear form, if we send it up, it will become what? Negative half, then du. So from here we can go ahead and integrate to get our answer. Let me use black so that you can see clearly. I'm not too sure if you can see with this color that I've picked. So we have 1 over 4, this is equal to, we have 1 over 4. If we integrate u raised to the power negative half, we add 1 to it, and we divide by what? The new power, which is what? Half plus 1. Then we add c to it. So we have 1 over 4. Then we have this becomes what? U power half on what? On half plus c. So this is equal to 1 over 4. And we have u power half. If I bring this to the top, it becomes 2. Okay, then plus c. So I can see that 1 over 4 multiplied by 2, we know the 2 going to itself 1, it will go here 2. So we have 1 over 2 u raised to the power half plus c. But remember, we said u is equal to what? 4s squared minus 1. So if we substitute that back, we have half, then into bracket 4s squared minus 1 raised to the power half plus c. And we can finally write this as 1 over 2 the root of what? 4s squared minus 1 plus c as our answer for integrating this function. So thank you so much for watching. This is how we integrate a function using the method of what? Substitution, and specifically for an indefinite integral. So thank you so much once again for watching, and I'll see you in the next video. Bye bye.